Okay, good evening everyone. I'm Shivani Dhok and I welcome you all for this week's tutorial session, that is week 11 for the course of digital signal processing and its application. So like every week, this week's tutorial will be divided in two parts. First part will be a quick recap of week 11 content, followed by the questions which are related to that content. So in this particular week, we looked at three different structures for realizing digital filter. First one was cascade structure, where we cascade the systems like this, where H1 and H2 either can be realized through direct form 1 or direct form 2 or lattice structure. Then we looked at parallel cascade parallel structure, so it's something like this. It looks something like this, where I have two systems in cascade, or it may be more than two or only one. And then we have another system which can be connected in parallel, and outputs, both of these outputs we add here to get the final output. And after that, at the end, we discuss this lattice structure. I won't discuss in detail lattice structure right now, but we'll definitely take one or two examples for this lattice structure. If you have any questions, then let me know. Otherwise, I'll start with today's tutorial, today's questions. Okay, if there are no questions, then let me just quickly start with the first question that I have planned to cover today. So the first question says that there is a degeneracy in the system if at any stage the lattice parameter kn takes the value what? So this is multiple answer correct question. So this degeneracy concept comes from when we look at the backward step in designing this lattice. So we know that the backward step is an equal to an plus 1 of z minus z to the power minus n plus 1 kn plus 1 into an plus 1 z inverse divided by 1 minus kn plus 1 square. So degeneracy occurs. Yes, sir.
Madam, are you hearing me?
Yes.
An plus 1 function is there, no? You are written in numerator, first term. First term you have written, no, madam, an plus 1.
Huh.
That is also Z inverse function, no?
No. So an plus 1
No.
is some 1
Just,
plus z inverse plus
yes,
something.
yeah. No. It is a Z inverse function, no?
Yes, yes.
You are
It's like
writing that
this.
here a small confusion is there, madam, in this one because while solving, we are getting what previously understood is it is that the Z inverse function is written as Z. And right side also, rightmost, you have see Z inverse, no? That is also a Z inverse. But I understood that we have to, wherever there is a Z, we have to inverse it and write. But then the function is of Z inverse. Why don't we write that as Z inverse, madam?
Sir, it's notation.
Then the function is Z inverse, no? Why a small confusion is there, madam, in this formula?
So
The
you
last.
write, okay, 1 second. You have a system 1 comma 1, so it starts from 0. So its h
Yeah,
of z is 1 plus z inverse. Why don't you
yeah.
write
Then
it
we
as
should
h of z
no.
inverse?
It is function of Z inverse, no? Because variable is Z inverse, no?
So do you write this as h of z inverse?
I see. Because the mathematical concept, not as a signal processing concept, is mathematical concept. We'll write with a variable.
So it is just a notation. Now what you keep in mind is here it is a function of z inverse, and when
Ah,
you write a n z inverse, then you need to
ah,
replace this z here by
yeah.
z inverse and then inverse. So this will be z.
Ah, that is right, madam. That is right.
Okay.
That is right. Yes, yeah, yeah, yeah. That is right.
Okay. Is this okay?
Okay. Okay, madam. Okay.
Yeah.
Perfectly okay. Thank you.
It's simple notation. So what you need to do is just look at the very basic form of a and z. You will see that it is a polynomial by polynomial in z inverse. But it is actually a function of z. So just take that form, and when you're writing a n z inverse, then wherever you find z, just replace it by z inverse. Simple. Okay. Okay. If that is clear, then where were we? We were discussing degeneracy. So this degeneracy occurs when 1 minus kn plus 1 square is equal to 0, which means that kn plus 1 can take value as plus minus 1 for all values of n. So basically we can just write it in general as kn can be equal to plus minus 1. So here plus 1 or minus 1, these are the two values that we can take. So these are the two options. Okay, so just to avoid any confusion again that there is kn and here we are having kn plus 1, I'll just do the small change here. Yeah, here also. Hmm. Okay, so degeneracy will occur if I have kn located at or kn equal to plus 1 or minus 1. This was done in lecture also, but since it was in previous assignments I took it. One more thing you need to take care of is this kn belongs to real set of real values. So this kn belongs to the set of real values, which means that it can't take complex numbers, and therefore we are just left with two possibilities, that is plus 1 and minus 1, and nothing else. I hope this question is clear. If you have any queries, then please let me know. Okay, if there are no questions, then let me go on to the next question. This is also very simple, just discussed in lecture also, but still I took it. So for nth stage system function, this polynomial an of this function an of z is defined as, so this by definition an of z is defined as en of z upon e0 of z. So this is by definition, and the option that satisfies this thing is this, that is option 2. So again, this is not anything new that is there in this question, just a question like a free marks giving question in last year's assignment. I hope there won't be any query in this particular question, so I'll quickly move on to more important questions that I wanted to cover today. So here is the first important question that is that asks us to do cascade realization. So it says that which of the following is our valid cascade realizations of the system whose difference equation is given here. And for cascade thing, what they are doing is they are considering two systems, so h1 of z h2 of z, and these are connected in cascade, and these should be equivalent to h of z, which will be the transfer function of this given system here. Okay, so the system that is given to us is y, sorry, y of n is equal to 3 by 4 y of n minus 1 minus 1 by 8 y of n minus 2 plus x of n plus x, sorry, plus 1 by 3 x of n minus 1. Now what we will do, we'll take all the y terms to left hand side. So we will have y of n minus 3 by 4 y of n minus 1 plus 1 by 8 y of n minus 2, which is equal to x of n plus 1 by 3 into x of n minus 1. Now we can take the z transform. So we'll take z transform of this. So we'll have y of z minus 3 by 4 z inverse into y of z plus 1 by 8 z to the power minus 2 into y of z, which will be equal to x of z plus 1 by 3 z inverse into x of z. We can take y of z common here. So y of z multiplied by 1 minus 3 by 4 z inverse plus 1 by 8 z to the power minus 2, which is equal to x of z. I can take common, multiplied by 1 plus 1 by 3 z inverse. So therefore y of z upon x of z, which is equal to h of z, comes out to be equal to 1 plus 1 by 3 z inverse upon 1 minus 3 by 4 z inverse plus 1 by 8 z to the power minus 2. And this thing we can factorize as 1 plus 1 by 3 z inverse upon, so denominator we can factorize as 1 minus 1 by 2 z inverse 1 minus 1 by 4 z inverse. Okay, so now let me just add one page and rearrange this little bit. Yeah, so now what we have is h of z. We have obtained this h of z here. So same thing we will be using. So this h of z here is 1 plus 1 by 3 z inverse divided by 1 minus 1 by 2 z inverse upon 1 minus 1 by 4 z inverse. And since we are doing cascade systems, this should be equal to h1 of z into h2 of z. So now let us figure out what are h1 of z and h2 of z for h1 of z into h2 of z for all of these systems. So for this system, h of z comes out to be equal to 1 plus 1 by 3 z inverse upon 1 minus 1 by 2 z inverse into 1 minus 1 by 4 z inverse. So one possibility is this answer. Now if you observe, they have mentioned is our valid cascade realization. So it is customary for us to look whether other possibilities are possible or not. So now one thing we can check is, first we can just rule out the possible possible options or impossible options for h of z. So if you observe here in numerator we have 1 plus 1 by 3 z inverse. Here for h2 numerator is 1 and here it is 1 plus 1 by 2 z inverse. And if I multiply these two, it's never going to give me this factor. So this option is ruled out. Similarly, here also we have 1 plus 1 by 2 z inverse multiplied by 1. Again, it would never give me this kind of structure. So again, this option is gone. And if we look at this structure, here we have 1 minus 1 by 4 z inverse multiplied by 1. Again, it won't give me this particular h of z, which means that a possible valid cascade realization is through this particular equation or this particular realization. Is it clear? Any questions? Yes, sir. Yes,
Madam,
sir.
in recent assignment, there is a bullet answers are there.
Huh?
One answer is cos n by n, another answer is minus 1 to the power of n by n. For that both are possible, then will it be considered for revaluation, madam? One answer is cos n by n, another is minus 1 by n by n. But second is solution of the first one. It is a bullet question, and two possible answers are there. When we answer either of them, can we get evaluation, madam?
I don't know, sir. Just put it in the portal. I'll check the question which you're referring to.
No. That I mailed to Aniket. Aniket told that both are correct, but it's a bullet question. But when we put the solution, we lost the mark.
Ask Aniket only regarding this, how they are
Okay,
going to handle.
thank you, madam.
Yeah,
Thank you.
he handles it. In this particular question, are there any queries? Okay. If there are no queries, then let me just move on to the next question. Okay, so this question says that consider two-stage lattice or consider two single-stage lattice filters cascaded together. The first stage has the lattice constant K1, which is pulled out ahead of the second stage with the lattice constant K2. We need to find the output from the second stage lattice filter given the input to the first stage is Xn. So input is given to the first stage and output is taken from the second stage. So it is like straight thing that is going on, like forward thing is only going on. So the structure that we are referring to is something like this. So we have E0. So this E0 is equal to E0 tilde, and input is given to this first stage. So this is my Xn. So this E0 will give, like, if I extend it, this will give me, okay, let me, 1 second, let me draw it properly. Yeah. So again, this is E0. This is having gain 1. And this is E1. This will have a gain of Z inverse. This will have a gain of 1. This is E1 tilde, like this. And then here we have K1. And here we have K1. So this is the first stage. Then we will have the second stage, which will be something like this. So this part will have a gain of K2. This part will have a gain of K2. This will give me my E2. And this will give me my E2 tilde. Yes, sir.
Excuse me, madam.
Yes.
Z inverse is delay now.
Yes.
Delay means it relates to phase term now.
Which term?
Z inverse, the Z inverse. We
Huh.
are writing Z inverse. The delay, it is refers to phase term now.
Phase term.
Yeah, delay means phase
Yes,
only.
correct.
But we cannot call that as gain now. Delay cannot be called as gain now.
Okay, did I mention gain?
Yeah, you
Sorry,
mentioned
it's
it as
delay.
gain. It's delay. Thank you. Thank you, ma'am.
Okay, so this is E2 here, and we will take output here as y of n at E2. Okay, so these are the structure which we are having, and this part here is the stage 2 lattice. Okay, now we need to figure out what is the output here. So for that, let us say that we are having, sorry, let me use a different color. So let me say that the output here is f1 of n, and here it is f2 of n, sorry, f1 tilde of n. So now let us first write down what is f1 and f1 tilde. So here f1 of n, so this f1 of n is coming like this, so that is x of n plus x of n minus 1 into k1. Okay, so this thing here is x of n plus x of n but delayed by 1 unit, x of n minus 1, and multiplied by k1. So this will be plus k1 x of n minus 1. Okay, now f1 tilde of n will be equal to x of n minus 1 plus x of n into k1. So this will be k1 x of n. So this is k1 x of n plus x of n minus 1. So these are the output from the stage 1 of lattice. We just copy this lattice again here just for reference. Now we need to figure out what yn is. So y of n is equal to f1n plus f1 tilde n minus 1 into k2. So this is equal to f1 of n plus f1 tilde n minus 1 into k2. So now let us substitute f of n and f1 of n and f1 tilde of n minus 1. So f1 of n is xn plus k1 into x of n minus 1. So let's substitute that. So this thing here is x of n plus k1 into x of n minus 1 plus k2 multiplied by f1 tilde n minus 1. So f1 tilde n is this factor here. So we need to delay it by 1 unit. So it will give us k1 into x of n minus 1 plus x of n minus 2. So this will give us k1 into x of n minus 1 plus x of n minus 2. So this gives us x of n plus k1 plus k1 into k2 into x of n minus 1 plus k2 into x of n minus 2. So this is my y of n. So this is y of n in terms of x of n for a two-stage lattice for FIR filter designing. Is it clear? So this is the final answer that we have obtained. If you have any queries, then please let me know. Otherwise, I'll move on to the next question. Okay. So the next question is, it says that in the parallel realization of the cascaded architecture of the discrete system shown in this particular figure. I hope this is visible to everyone. H of z is written in partial fraction form as this equation, and which of the following is are true, and this is a multiple correct answer. So this is the system which is given to us, and we need to figure out what is the value of a b c d in the given function. So first let us figure out the entire h of z. So for that, let this particular thing be h of z, sorry, h1 of z, and this particular thing here be h2 of z. So this h1 of z comes out to be, so if you observe here, this is a feed forward thing and this is a feedback thing, and in h1 of z part there is nothing feed forward, so everything is feedbacking here. So therefore in numerator it is 1 upon this gain is 1, so we'll have a 1, then z inverse multiplied by negative of this quantity, so minus 2z inverse, then here is minus 0.25, so it will be z inverse into z inverse, so that will be z to the power minus 2 multiplied by 0.25 z to the power minus 2. So this is h1 of z, and for h2 of z we have both feedback and feed forward thing. Now note here, this form is represented through direct form too, which means this particular part is direct form, sorry, feed forward part, and this part is feedback part. So the feed forward will come in the numerator, so in the numerator we'll have this gain is 1 plus z inverse into 0.25 okay, and in the feedback part we will have this gain as 1 minus 3z inverse, so this is 3, so z inverse into minus 3 plus 0.2 into z inverse into z inverse plus 0.2 z to the power minus 2. So this is h1 of z and h2 of z. So h of z will be multiplication of these two factors. So therefore h of z will be equal to h1 of z into h2 of z. So this comes out to be equal to 1 upon 1 minus 2z inverse plus 0.25 z to the power minus 2 multiplied by 1 plus 0.25 z inverse divided by 1 minus 3z inverse plus 0.2 z to the power minus 2, and this comes out to be equal to 1 plus 0.25 z inverse upon 1 minus 2z inverse plus 0.25 z to the power minus 2 into 1 minus 3z inverse plus 0.2 into z to the power minus. Okay, so this is what we are having. Let me number it as equation 1. Now another thing that is given to us is this particular equation where h of z is equal to this particular form. So now let's get to this form. So from given thing we have, so given to us is h of z is equal to a plus bz inverse upon 1 minus 2z inverse plus 0.25 z to the power minus 2 plus c plus d z inverse upon 1 minus 3z inverse plus 0.2 z to the power minus 2. So now I can just multiply this with this and multiply this with this. So I'll have h of z is equal to a plus bz inverse multiplied by 1 minus 3z inverse plus 0.2 z to the power minus 2 plus c plus dz inverse multiplied by 1 minus 2z inverse plus 0.25 z to the power minus 2 divided by 1 minus 2z inverse plus 0.25 z to the power minus 2 multiplied by 1 minus 3z inverse plus 0.2 into z to the power minus 2. Now let me number this as equation 2. Now if I compare equation 1, so if I compare these two equations, that is this one and this one, so from both of these, this denominator part is same. So both of them are having same denominators, which means they should have same numerators also. So this quantity here should be equal to this quantity. So therefore, what we have is, therefore a plus bz inverse multiplied by 1 minus 3z inverse plus 0.2 z to the power minus 2 plus c plus dz inverse into 1 minus 2z inverse plus 0.25 z to the power minus 2, and this thing should be equal to the numerator of equation 1, which is 1 plus 0.25 z inverse. So this is 1 plus 0.25 z inverse. Let me number this as equation 3. So now let us just consider or focus on this LHS. So this now I can simplify as a minus 3a z inverse plus 0.2 a z to the power minus 2 plus b z inverse minus 3b z to the power minus 2 plus 0.2 b z to the power minus 3 plus c minus 2c z inverse plus 0.25 c z to the power minus 2 plus dz inverse minus 2d z to the power minus 2 plus 0.25 d z to the power minus 3. So now we'll collect the coefficients corresponding to z1, z2, sorry, we'll combine the coefficients of all the powers of z inverse and constants. So for constants we have a and c. So this thing is equal to a plus c. Then we have z inverse. So coefficients corresponding to that are minus 3a, b, 2 minus 2c, and d. So this is minus 3a plus b minus 2c plus d. Then for z to the power minus 2, we have 0.2a minus 3b minus 0.5 minus 0.25c and plus 0.25c and minus 2d. So this is equal to 0.2a minus 3b plus 0.25c minus 2d plus z to the power minus 3. And for this again we'll have two terms, so this one and this one. So this thing is equal to 0.2b plus 0.25d, and this whole thing should be equal to 1 plus 0.25 z inverse. So now comparing coefficients of all the powers of z on the left hand side and right hand side, what do we have? We have a plus c is equal to 1, which means that c is equal to 1 minus a. Then we have, so this equation is done. Then we have this equation. So we have 0.2p plus 0.25d equal to 0, which means that d is equal to minus 0.2 upon 0.25b, which means that this is minus 0.8b. Now we are left with two more equations. So one is corresponding to z inverse and one is corresponding to z to the power minus 2. So from here we have, so from the first term we have minus 3a plus b minus 2c plus d is equal to 1. 0.25. So now what we will do is we'll reduce it to a two variable equation. So we'll substitute this 1 and 2 in this. So what we get is minus 3a will be as it is, plus b will be as it is, minus 2 into c is 1 minus a, plus d is minus 0.8b. And if you simplify this, this thing comes out to be minus a plus 0.2b is equal to 2.25. So let me number this as equation number 3. And in similar way we have this third equation, this one corresponding to 0.2 z to the power minus 2. So this thing, if we compare its coefficient, compare the coefficient with left hand side, there is no z to the power minus 2 term, so this thing will be equal to 0. So again let us just substitute it. So the 0.2a will be as it is, minus 3b plus 0.25, 1 minus a minus 2 into minus 0.8b is equal to 0. And if we simplify this, this comes out to be equal to minus 0.05a minus 1.4b is equal to minus 0.25. And if we divide this entire equation by minus 0.05, this reduces to a plus 28b, which is equal to 5. And let me number this as equation 3. So now we have two equations. So we have equation 3 as minus a plus 0.2b as 2.25 and a plus 28b as 5. So if we add this, we have 28.2b is equal to 7.25, which gives us b as 0.257. Then if b is this, then we can find a as 5 minus 28b, and this comes out to be equal to minus 2.196. Now we have the value of this B, we have the value of A, and now we can use this equation 1 and 2 in order to find the value of C and D. Okay, so the C is 1 minus A, so this comes out to be equal to 3.196, and D is equal to minus 0.8 into B, so this is minus 0.8 into 0.257, so this comes out to be equal to minus 0.2056. So this is what we are having here. So this thing is the value of C and this thing is the value of D. This is not the end of this question. This was a multiple choice question and multiple correct question. So let me just template. Let me just take this page here. So this is what we are having. So let me just quickly write down the values of A, B, C and D, whatever we had obtained. So we had obtained A as minus 2.196. We had obtained B as 0.257. Then we have obtained C as 3.2, and we had obtained D as minus 0.21. Okay, so let us check with the first option if it is correct. So first option says that A is less than 0. So the value of A which we had obtained was minus 2.196, which is indeed less than 0. So this option is correct. Now let us look at the next thing, that is, it says that floor of B is equal to floor of D. So what does this floor mean? So if I have a number something like A plus C, D, E, F, where everything A, B, C, D and F belong to integers, then this particular function will give me a value of A. So basically we just need to remove the decimal points here, or rather saying in that way, we'll need to choose the smallest integer less than that particular value. So here floor of B is equal to 0 and floor of D, so the smallest integer less than this will be minus 1. So if that is the case, so this thing is 0 and this thing is minus 1, which means that this is not correct. Next thing says that floor of C is equal to 4. So floor of C, if you observe here, this is 3.2, which means its floor will be 3. So again, this is not correct. This is also not correct. And the last option is D greater than 0. So this D is equal to minus 0.21, which is less than 0, which means that this option is also not correct. So the only option that is correct is A less than 0. Is it clear? Any questions in this particular part? Okay, if there are no questions in this particular part, then let me move on to the next question. Okay, thanks. Thanks for feedback. Okay, so let me start with the next question. So it says that for the system below, find a parallel form representation. Okay, so we need to find a parallel form representation. So an issue with this particular question is, so the issue with this particular question is that the numerator degree and the denominator degree is same. So we need to reduce the numerator and denominator degrees here. So for that, what we will do is, let us take this h of z, and from numerator we'll just take 2 common. So we will have 16 plus 9z inverse minus z to the power minus 2 upon 8 plus 2z inverse minus z to the power minus 2. Now this thing I can write as 2 inside the bracket. I can write this 16 as 8 plus 8. Then this 9z inverse I can write as 2z inverse plus 7z inverse minus z to the power minus 2 divided by 8 plus 2z inverse minus z to the power minus 2. So this thing here I can now write as, I can take this 8, this and this in one bracket. So this will be 8 plus 2z inverse minus z to the power minus 2 plus 2 times 8 plus 2z inverse divided by 8 plus 2z inverse minus z to the power minus 2 divided by 8 plus 2z inverse minus z to the power minus 2. Yes, sir.
Madam, some correction is there, I think, here. 8 plus 7 z inverse. Here. At the second numerator. That only.
Thank you. Okay. So this is what we are having. So now I can simply cancel out these terms. So this gives me 2 plus
Ah,
2 into
mm,
8 plus 7z inverse upon 8 plus 2z inverse. So now from denominator also I can take out 8 common. So that will
ఎందుకు
give me
ఏం దిగుతావు ఏం దిగుతావు తల్లి
1 plus 1 by 4 z inverse minus 1 by 8 z to the power minus 2, and this gives me 2 plus, so this will give me 2 plus 7 by 4 z inverse upon 1 plus 1 by 4 z inverse minus 1 by 8 z inverse. Now this factor is sorted. This is okay. Now we can just use partial fractions method to simplify this part. So now if we consider this thing here, let's consider this separately. So we have 2 plus 7 by 4 z inverse upon 1 plus 1 by 4 z inverse minus 1 by 8 z inverse. This I can write as 2 plus 7 by 4 z inverse divided by, and this denominator I can factorize as 1 minus 1 by 4 z inverse into 1 plus 1 by 2 z inverse. It's 1 by 4, 1 by 4. Okay. Yes, sir.
some degree difference is there. You please observe. 1 by 8, that's the power of minus 2. Denominator. Left side denominator, madam. Left side denominator.
Understood, sir. 1 second. I missed on some pen. 1 second. So this is equal to, I can write it as A upon,
Right. ఏమిటిది నెలకొసుకుంటాయి
plus B upon 1 minus 1 by 4 Z inverse. Okay. Yeah. So now I can write this as 2 plus 7 by 4 Z inverse is equal to A into 1 minus 1 by 4 Z inverse plus B into 1 plus 1 by 2 Z inverse. Now let us substitute Z inverse as 4 So then we will have 2 plus 7 by 4 into 4, which is equal to this term here will go to 0, b into 1 plus 1 by 2 into 4. So this comes out to be 9 equal to 3b, which means that b is equal to 3. Similarly, if I substitute z inverse equal to minus 2, then this comes out to be equal to 2 minus 7 by 4 into 2 is equal to a into 1 plus 1 by 4 into 2, and this will give me a as minus 1. Okay, so now I have a equal to minus 1 and I have b equal to 3. I can substitute it in this form. So therefore 2 plus 7 by 4 z inverse upon 1 plus 1 by 2 z inverse multiplied by 1 minus 1 by 4 z inverse is equal to minus 1 upon 1 plus 1 by 2 z inverse plus 3 upon 1 minus 1 by 4 z inverse. So therefore h of z comes out to be equal to 2 plus this quantity. So then this will be equal to 2 minus 1 upon 1 plus 1 by 2 z inverse plus 3 upon 1 minus 1 by 4 z inverse. And this we need to realize using parallel combination. So for that, let us now do it one by one. So let me just color it in different colors. Yeah, so that it's easy to understand what we are realizing. Okay, yeah. So here we have x of n, or let's say x of z or x of n, anything is okay. Then here again we'll have the same thing here. Then first of all, let us realize this 2. So this 2 is simply a gain of 2 here and nothing else. Now let us now realize this particular term here. So we are having a minus 1. So let's have it here minus 1 like this. And then we have a feedback coming up z inverse, and this feedback thing will have a gain of minus 1 by 2, and this will go upwards. So this is this red term. So let me just take this diagram to the next page. And this is what we are realizing. So now we need to realize this 3 upon 1 minus 1 by 4 z inverse. So then we will have a gain of 3 here. Then we have delay, and we here have minus 1 by 4, which means I'll have a gain of 1 by 4 here. Then we have this thing here, and all of these things get added. Should put arrows, otherwise it doesn't make sense. Like this, and this is my y of. So this is the parallel form representation of the given system. Is it clear? Okay. So if there are no questions, then let me just quickly move on to the next question. So this is the next question that I am having here. So it says that find y of z upon x of z in the following signal flow diagram. So this is what we are having here. This is the signal flow diagram that is given to us. Let me just mark things properly for you. This is x of z. Yeah, this is what is given to us. So this is the signal flow graph that is given to us, and we need to figure out what is y of z upon x of z. Okay, so now let me just mark these stages. So if you observe carefully, this is for an IR filter, and we take output from E0. So this is E0 offset. This is so E0 tilde. This is E0 offset. This is E1 offset. This is E1 tilde offset. This is E2 offset, and this is E2 tilde offset. Okay, this is we are having, and we have some relations. So what relations do we have? So we have this En plus 1z is equal to En of z plus Kn plus 1 into En tilde z into z inverse, and En plus 1 tilde z is equal to En of z plus, sorry, to Kn plus 1 plus z inverse into En tilde z. Okay, this is what we are having here. Okay, so now let us start with stage 0. So for we have this stage 1. So for this we have E1 of z equal to E0 of z plus K1 z inverse into E0 tilde of z. So this E0 and E1 tildes, so this E0 tilde and this E0 tilde and this E0 is equal to y of z, and this thing here is minus K1 and this thing here is K1. So this is standard lattice structure. So this thing will come out to be equal to y of z plus K1 is 1 z inverse into y of z. So this thing is equal to y of z into 1 plus z inverse. Now similarly we'll repeat the same steps for stage 2. So for stage 2, and here in stage 2 we just need x of z. We know the value that x of z is equal to E2 of z. So let us just focus on E2 of z. So from this equation which we just wrote, from this equation E2 of z, which indeed is equal to x of z, this comes out to be equal to E1 of z plus K2 z inverse into E1 tilde of z And this comes out to be equal to even tilde of z is y of z into 1 plus z inverse. And sorry for this, we'll need even tilde. So let's just first find that out. So this even tilde will be equal to, from this particular equation, will be equal to E0 of z into k1 plus z inverse into E0 tilde of z. So this will be equal to y of z, k1 is 1 plus z inverse into y of z, and this comes out to be equal to y of z into 1 plus z inverse. So this is what we are having here, plus k2z inverse into y of z into 1 plus z inverse. Okay, so therefore x of z is equal to y of z common. We have 1 plus z inverse plus, so if you observe this here, this factor here is minus k2 and this factor here is k2. So we have 2z inverse into 1 plus z inverse. I can take out 1 plus z inverse common. So therefore y of z upon x of z, which is equal to h of z, is equal to 1 upon 1 plus z inverse into 1 plus 2z inverse. Is this part clear? Any questions? Okay, if there are no questions, then let me move on to the next. K1 and K2 values. Okay, so Sujata, if you look at the structure of this thing, lattice structure for IIR filters, maybe in probably second last lecture, so you will observe that this thing here, or let me, yeah, this thing here, for any nth stage, this thing here, whatever goes down is kn. So for first stage it will be k1, and this thing here, whatever goes up is k minus of kn. So if you observe these values which are going up and down here, or if you observe these gains, so this particular thing will be my k1 and this particular thing will be my minus k1, which clearly say that k1 will be equal to 1. Similarly, this thing here is my stage 2 lattice. So whatever is going here will be minus of k2, and whatever is coming here will be equal to k2. So if we observe, this part is k2, this is minus k2, which means that k2 is equal to 2. So I like you to refer to the reference structure which we have discussed in the lectures. So whenever you have these kind of lattice things now, just try to remember that structure, or keep it aside, keep it with or keep your notes open for final exam. Just keep that thing in mind, or at least keep the knowledge of these two equations. So even if you forget these two equations, you can construct the lattice using these thing. So for that, just refer to the lecture how this lattice is getting constructed. So if that you know, then you don't need to remember any kind of structure. I hope I am clear. If you have further queries, then please let me know. Otherwise, I'll go on to the next question. Okay, thanks. So let's quickly go to the next question. Yeah. So this is the next question that we are having. So again, a mistake by adding these directly. Let me just quickly retrace the diagram for you people so that it's visible. Just a moment, let me just complete this. Yeah. So again in this question we need to find y of z upon x of z. So now if you observe carefully, this is basically a parallel structure or a parallel realization of two systems. So the first system is this one and second system is this one. So let me highlight it using different colors. So this one here, this one is h1 of z, and this one here, this one here is h2 of z. Okay, so for this particular system we are having a parallel connection of two systems. First one is h1 of z and second one is h2 of z. So let us first write this observation. So the observation h of z is parallel connection of two systems h1 and h2. So therefore h of z is equal to h1 of z plus h2 of z. Now look at this h1 of z. So what is happening here? Your x of z is going here. It's getting multiplied by z inverse, and then you are getting this point here. So if I mark this point here, so this thing is simply z inverse into x of z. So this point, whatever I have marked, this is output of first system, which means output of like whatever I'm getting at this part divided by the input will give me h1 of z. So therefore my h1 of z will be only equal to z inverse. Okay, so let us quickly write that down. So h1 of z, just use red pen so that it's consistent, h1 of z is equal to z inverse. Okay, now look at h2 of z. Look at this particular structure and let us see the structure which we had in the previous question. Let us see this structure. So this structure and the structure which we are having as H2 are exactly the same structures. So this structure which we are having is exactly the same structure. You observe the K1 is 1 and the K2 is 2, which clearly indicates that both the systems are same, which means that H2 of Z is equal to the system which we have realized, which was given in the previous question. So let us write that down. H2 of Z is equal to 1 upon, so what was the system? It was 1 upon 1 plus Z inverse plus 1 plus 2Z inverse. So we have 1 plus Z inverse into 1 plus 2Z inverse, and why? From question, from previous question. Okay, and we know that H of Z is equal to H1 of Z plus H2 of Z. So therefore H of Z, which is equal to H1 of Z plus H2 of Z, this comes out to be equal to Z inverse plus 1 upon 1 plus Z inverse into 1 plus 2Z inverse. So this is the H of Z, which is nothing but Y of Z upon X of Z. So this is the final output that we are having, the final answer that we are having. Any questions in this part? Okay, just a minute. Okay. If there are no questions in this part, let me move on to the next question. So this ninth question says that how many unit delay elements will be required if we realize the given H of Z using the parallel architecture with a lattice structure. Okay, so we need to realize this by the lattice structure, and we know that for a lattice structure the condition that we have is the numerator degree should be less than the denominator degree, but however it is higher in this case, or less than or equal to is the condition, so here it is higher. But if we observe, then this part here is exactly identical to this part here. So what we can do is we can just separate these two things into two different fractions. So we'll have this H of Z, I can write as 2Z inverse into 1 plus 1 by 2Z inverse plus 1 plus 1 by 3Z inverse divided by 1 plus 1 by 2Z inverse multiplied by 1 plus 1 by 3Z inverse plus 1 plus 1 by 4Z inverse divided by 1 plus 1 by 2Z inverse into 1 plus 1 by 3Z inverse. So here these two terms get cancelled. So what we are left with is 2Z inverse plus 1 plus 1 by 4Z inverse upon 1 plus 1 by 2Z inverse upon 1 plus 1 by 3Z inverse. Okay, so now this is just an FIR term. This will require one delay. And this term we will realize using lattice. And for lattice, so for lattice structure, number of unit delays is equal to degree of denominator polynomial. So in this question, degree, what is the degree in this question? So here it is 1 degree multiplied by 1 degree polynomial, so the degree will be equal to 2. So therefore, total number of unit delays is equal to 1 for the FIR, so 1 plus 2 for the lattice structure, that is 2, 1 plus 2 is equal to 3. So we require 3 unit delays to realize this particular thing using parallel architecture with a lattice. So parallel thing is coming up because I'm having an FIR added to a rational thing, rational Z transform. So since we are having an addition here, we can represent, we can realize this through a parallel architecture. Is this clear? Any questions in this part? Okay. So if it is clear, then let us quickly move on to the last question that I have planned to cover today. So this is the question where we will see how to construct the lattice structure for any given polynomial. So the question here is realize the following system function using the lattice structure. And the given system function is h of z equal to 1 plus 1 by 4 z inverse upon 1 plus 1 by 2 z inverse into 1 plus 1 by 3 z inverse. So now let us quickly write it. Yes, sir.
Madam, when this question is given, is it series or preferred or parallel or preferred?
Sir, lattice structure.
Yeah, no, no, no. You are doing series or parallel, like that H1 plus H. Some you are doing, no. Some of the two transfer function, that is parallel, no.
Where?
No, no. We are doing, no. Two transfer functions we are doing H1Z plus H2 of Z, and we are using lattice structure.
In which question?
Sorry, madam. Sorry. Okay. Please go ahead, madam.
Okay. If you are referring to this particular structure, then we are having H1 plus H2 here. So that is a parallel structure. Similarly, here we had a parallel structure which involved a lattice. So again we had H1 plus H2. So yes, this was a parallel structure. This was a parallel structure involving lattice. This was also a parallel structure involving lattice. However, when we are doing this particular question, we don't need to do, or we are not asked to do a parallel architecture. We just need to focus on lattice structure. So this particular question, we just need to use lattice structure in order to realize this question. Another thing is we are given this transfer function and the numerator degree is less than the denominator degree, which means that we can simply use the lattice structure as it is. So therefore, I can write this h of z as 1 plus 1 by 4 z inverse, and in the denominator I can expand this as 1 plus 1 by 2 plus 1 by 3 z inverse plus 1 by 6 z to the power minus 2. This comes out to be equal to 1 plus 1 by 4 z inverse 1 plus 5 by 6 z inverse plus 1 by 6 z to the power minus 2. And in the lecture we had discussed this, that this thing is equal to m equal to 0 to n, and here n means yes sir, please ask the question. If you're
I didn't
speaking,
understand the question, madam.
no, not you sir, Venkat Reddy sir have asked some question. He has raised the hand, so if he's speaking then he is not audible. Okay.
Hello, madam.
Yes. Yes sir.
Hello.
Yeah, yeah. Hello. You are not audible. Please unmute yourself and then speak.
Hello, madam.
Yeah, now you are audible. Please say. Hello. Sir, if you are not audible, if you have a question, then just put it in the chat box. I'll read it. Okay. So this h of z is equal to 1 plus 1 by 4 z inverse upon 1 plus 5 by 6 z inverse plus 1 by 6 z to the power minus 2. So this is equal to summation m equal to 0 to n. N is the degree of denominator, which is equal to 2 cm into am tilde z divided by a to z. Okay, so now first thing that we will do is we'll realize the denominator. So step 1 in this thing, so step 1 is realizing denominator. So here what we know is this a2 of z is equal to this denominator polynomial, which is 1 plus 5 by 6 z inverse plus 1 by 6 z to the power minus 2. So this is 1 plus 5 by 6 z inverse plus 1 by 6 z to the power minus 2. And note that kn is the coefficient of z to the power minus n in an of z. Now why do we need kn? We need kns to, so these kns are basically my gains in the lattice structure. So we need these values of kn, and that is the thing that we need to determine from whatever transfer function is given to us in order to realize our lattice structure. Okay. So in that situation, if kn is the coefficient of z to the power minus n in an of z, so in a2 of z, the coefficient of z to the power minus 2, which is 1 by 6, will be equal to k2. So therefore, let me number this as 1. Therefore, from 1, k2 is equal to 1 by 6. So this is the value of k2 that we are having. Okay, so now we have k2. Next thing that we need to do is, so this is for the second stage, we need to figure out the gain for the second stage also. So for this, what we'll use the backward step formula which we were having. So we'll use Kn is equal to, sorry, An of z is equal to An plus 1z minus Kn plus 1 into An plus 1 tilde z upon 1 minus Kn plus 1 square. So this formula we know. Now we'll make use of this formula for A2. So therefore, from this formula, A1 of z will be equal to A2 of z minus, what is K1? K2 of, so K2 into A2 tilde z upon 1 minus K2 square. Now we know what is A2. A2z is this thing. So let me just write it again. We have A2 of z as 1 plus 5 by 6 z inverse plus 1 by 6 z to the power minus 2, which means that A2 tilde z is equal to, just reverse the coefficients of all the variables. So for constant will be now coefficient of this. So this will be 1 by 6 plus 5 by 6 z inverse, and z to the power minus 2 will have now the coefficient as 1. So z to the power minus 2. And we had figured out K2 as 1 by 6. So we have all the material that we need. So therefore A1 of z will be equal to A2 of z, which is simply 1 plus 5 by 6 z inverse plus 1 by 6 z to the power minus 2 minus 1 by 6 into 1 by 6 plus 5 by 6 z inverse plus z to the power minus 2 divided by 1 minus 1 by 6 square. Okay, so now if you observe this term and 1 by 6 into z to the power minus 2, this term gets cancelled. So now what we are left with, we have 1 minus 1 by 6 square. So this is 1 minus 1 by 6 square plus z inverse into 5 by 6 minus 1 by 6 into 5 by 6. So I can take 5 by 6 common, to 1 minus 1 by 6 divided by 1 minus 1 by 6 square. So this I can simplify as 1 plus z inverse into 5 by 6 into 1 minus 1 by 6 divided by 1 minus 1 by 6 into 1 plus 1 by 6. These things get cancelled. This reduces to 1 plus z inverse into 5 by 6 divided by 7 by 6, which is equal to 1 plus 5 by 7 z inverse. So this thing here is A1 of z, and now K1 of z will be coefficient of z inverse. So therefore K1 will be equal to 5 by 7. So this is the value of K1 that we are having. Okay, so only two things that we need for realizing the denominator structure. One is K1 and one is K2. So we have obtained K1 as 1 by 6 and K2 as 5 by 7. This is what we have obtained, and now we need to construct the lattice. So let me just quickly draw the repeating structure. For lattice, and that repeating structure looks something like this. So we have stage En, or we have output En here. Sorry, we have value en, we have en tilde. This in en tilde gets z inverse. This gets passed as it is, sorry, in opposite direction. Then this will go up. This will have minus kn plus 1. Then this will have kn plus 1, like this. Here, this will go here, and this thing will go here. Here we will be having en plus 1. Here we will be having en plus 1 tilde. So this is the structure that we are having. Now this structure repeats itself. Yes.
Madam, you gave arrows in reverse order for kn plus 1. Arrows must be, direction must be opposite.
No, I think.
Madam? Forward, no, madam. Arrows must be in forward direction, no. But what you gave are in reverse. Please check.
These arrows?
No, not those, madam. Kn plus 1.
This one?
Yeah, that arrow, upwards. Both are in reverse order. Kn plus 1 minus Kn plus 1. Oh, your diagram is in reverse order. Oh,
Huh.
okay, madam. No, but madam, from En, you will get En plus 1, no? Then these arrows are wrong. Arrows in the horizontal lines.
No, they are
They are
correct,
wrong.
sir.
Please check, madam, with the standard one. We'll go back and show the standard one. Previous examples. Yeah, magnify it, madam. Oh, I think it is not correct, madam. Yeah, arrows must be in reverse direction.
No,
Something
sir,
wrong.
it's correct. It's correct. It is correct.
Okay. Okay.
Just a minute. I'll tell why it is correct.
Ah.
Okay. So this is what we are having. So let's start with en tilde first. En plus 1 tilde. Okay. We'll start with en plus 1 tilde. Okay. So now this point is en plus 1. This point is en. This gets multiplied by kn plus 1. So this is this factor. Then we have en tilde that gets multiplied by z inverse. It gets here. This part is correct? Okay, so this part is correct. Now, for IIR structure, what we did? For IIR structure, we took this equation and manipulated this. Right. We wrote this as en equal to en of z equal to en plus 1z minus kn plus 1 into en tilde z into z inverse. Okay, so now you look at this en. Look at this en. This en should be equal to en plus 1. So this is en plus 1 here. And minus kn plus 1 into, so we have this en tilde coming here. En tilde gets multiplied by z inverse. Huh. This thing gets multiplied. Where am I? I want to go. I want this thing. So I am here right now, en tilde z inverse, which gets multiplied by kn minus of kn plus 1. So here I am having, and this gets here. So this point is en, this point is also en. So en tilde z inverse and this thing, and then plus en plus 1. Okay. So this is what we are realizing for IIR systems. This is not for FIR, this is for IIR. That's why we are doing this particular thing. So this lattice structure is correct. Just refer to the last lecture of lattice structure in the videos. It will be much more clear. But yeah, this is correct structure. Nothing is wrong here. Is it clear? Hello, is it clear? Okay, I assume it's clear to the person who asked it. So let's move on to the next step of this. Yeah, so we wanted to realize this thing. I'll keep this diagram as a reference here. I know the font is small, but still. Then when we are realizing it, then k1 was obtained as 1 by 6, and sorry, k2 was obtained as 1 by 6, and k1 was obtained as 5 by 7. So we go on doing it in backward direction. So this thing will be equal to E0, this thing will be equal to E0 tilde. These are same, and we take output from this part. So this is my y of, okay, let's not do this right now. Okay, so this we are having. Then we'll have, okay, so this thing will get passed with z inverse like this here, and we'll have arrows in the opposite direction here. This gets multiplied by minus k2. Minus k2 will be minus 1 by 6. This gets multiplied by 1 by 6, which is k2, and this will give me E1 and E1 tilde. So this is my first stage. After that, I need to look at the second stage. So for second, sorry, this is my first stage. Now I need to, this is not 1 by 6 and 1 by 6, this is k1 and minus k1. So this is first stage, this is minus k1, which is minus 5 by 7, and this is k1, which is 5 by 7. Then we need to realize the second stage. So for second stage, again I'll have these things. So I'll have z inverse here like this, and like this, here, here, here. Here I'll have E2, and here I'll have E2 tilde. Okay, now I'll have a branch going like this. Here I'll have minus k2, which will be minus 1 by 6, and a branch going like this. This will be 1 by 6. So this is what I am having, and I'll give my input here, which is x of z, or I'll have my x in, applied at this particular point. Okay, now next thing we need to do is we need to complete the lattice structure. Step 2. Step 2, realize numerator. So in the numerator, what do we have? If we go back to this very initial stage where we wrote it, so this is what we are having. So this numerator, this thing is equal to this quantity here. Okay, so let me just write it down properly there. So 1 by, sorry, summation m equal to 0 to 2 cm into am tilde z is equal to numerator, which is 1 plus 1 by 4 z inverse. So this thing I can write as c2 into a2 tilde z plus c1 into a1 tilde z plus c0 into a0 tilde z, but a0 tilde z is 1. So this is equal to 1 plus 1 by 4 z inverse. Now what I'll do is I'll substitute a2 tilde z and a1 tilde z. So c2 into a2 tilde we had found out. So a2 tilde was 1 by 6 plus 5 by 6 z inverse plus z to the power minus 2. So this thing is 1 by 6 plus 5 by 6 z inverse plus z to the power minus 2 plus c1. So c1 into a1z, a1 tilde z, we had found out a1z. This was my a1z. So a1 tilde z will be equal to, just reverse the coefficient, so that will be 5 by 7 plus z inverse. So this is my a1z. So a1z is 5 by 7 plus z inverse plus c0 equal to 1 plus 1 by 4 z inverse. Okay, now compare the highest degree on both coefficients of highest degree on left and right. So the c2 is coefficient of z2 only, and if I compare it with the coefficient of z to the power minus 2 in the RHS, it will be equal to 0. So c2 is the coefficient of z to the power minus 2, therefore c2 comes out to be equal to 0. Okay, now what I'll do is, now I'll subtract this entire term from both the sides. So what I'll get is c2 is 0. So after subtracting this particular term from both the sides, I will get c1 into 5 by 7 plus z inverse plus c0 equal to 1 plus 1 by 4 z inverse. Now again we need to compare the coefficients of highest degree. Now the highest degree is 1 and the coefficients are c1 and 1 by 4, which means that c1 is equal to 1 by 4. And now what we need to do is we need to subtract this term from both LHS and RHS. So if we do that, then we'll be left with c0 equal to 1 plus 1 by 4 z inverse minus 1 by 4 into 5 by 7 plus z inverse. So the z inverse term gets cancelled, and what we are left with is 1 minus 5 by 28, which comes out to be equal to 23 by 28. So what do we have? We have c0 as 23 by 28. We have c1 as 1 by 4, and we have c2 as 0. Just a minute. Give me a minute. Okay. So now what we do? So in order to realize this thing, we take the structure which we had earlier. And in this structure, what we do is we take this part, multiply it by c0, then we take e1 tilde and multiply this by c1, and we take e2 tilde and multiply it by C2, and all of these things get added, and this gives us Y. Now in our case, C0 was obtained as 23 by 28. So the C0 comes out to be 23 by 28. C1 came out as 1 by 4. C1 is 1 by 4, and C2 is equal to 0. So I can simply remove this branch and take my output from this place. So this is the lattice structure for the given transfer function. Is this clear? If you have any questions, then let me know. Okay. So this was the last question that I have planned to cover today. Sujata, whatever doubts you have, I haven't seen the assignment yet. Just post it in the forum. I'll solve it in the next tutorial, definitely. So whatever assignment solutions are released already, that I can discuss, but I haven't prepared it yet. So you post the questions or post your queries. I'll solve that in the next tutorial. And hopefully there will be a summary session also. So from all the assignments, if you have any queries, then just put it in the what do we call that, forum. I'll solve those doubts in the in that summary session as well. Yeah, thanks. Okay. So if you have no further questions, then you are free to leave the meeting. Thank you for attending today's session.